Hello everyone, and welcome to Jam Academy. In this very short lesson, we will talk about the mathematical definition of work. Recall that work is the mechanical transfer of energy by an external force when the force moves its point of application in the direction of its displacement. So how do we calculate the work done by a force on a system? Now, the work done by a force on a system is simply given by the magnitude of the force in the direction of the displacement of the point of application of the force and the magnitude of that displacement. In other words, work is equal to F in the direction of the displacement multiplied by the magnitude of that displacement. So this is the mathematical definition of work. Now, what you need to bear in mind is that force, the SI unit of force is the Newton, and the SI unit of displacement is the meter. So this implies that the unit of work is simply Newton meter. Now, by definition, work is the mechanical transfer of energy, or work is simply the transfer of energy. So the unit of work is the same as the unit of energy, the joules. In other words, 1 joules is equal to 1 Newton meter. So this is the SI unit of work. But the question remains, what if the force is not entirely in the direction of the displacement of the point of application of the force? So what you do is, we will resolve this force into two components. You have the component in the x direction. This is F cosine theta, and the component in the y direction. This is F sine of theta. So the work done by the force F, in this case, is going to be equal to the component of the force in the direction of motion multiplied by delta x. So this is going to be equal to F cosine theta multiplied by delta x. In other words, W is equal to F delta x multiplied by cosine theta. This is the more general definition of work. Keep in mind that theta is the angle between the direction of the force and the displacement of the point of application of the force. Let me say that again. The angle theta is the angle between the direction of the force and the displacement vector. So essentially, this is all you need to know about the mathematical definition of work. But sometimes, not just one force acts on an object. Different forces act on a particular object. So how do you calculate the total work done? Now, there are two ways that you could calculate the total work done on an object. You can calculate the total work done on an object by first calculating the resultant force on the object, or you can calculate the individual work done by the individual forces and then you sum them up. So in other words, the total work done is equal to the net force acting on the object multiplied by the displacement of that object, which will be equal to the net force is just the sum of forces acting on that object multiplied by the displacement of the point of application of the force entirely. So please, if you have any questions regarding how to calculate the work done on an object, please ask in the discussion forum below. I'm going to do some examples to illustrate how you can actually use this formula to calculate the work done by a particular force on a system. Thank you so much, and bye-bye.
Manhattan, Brooklyn.